Okay, so in this case, we've got magnesium sulfate. The hydrated mass is 16.42 grams, and we've been told that the mass of the anhydrous sample is 9.22 grams. And so we effectively need to work out the value of X in this question using the information we've been provided. Right. Now, the question X is effectively asking is, well, for every 1 mole of MgSO₄, how many moles of H2O are we going to have, right? That is the key question. So essentially, what we're doing is we're trying to go through the steps of working that out. However, what we've been given are masses, and when it comes to making these comparisons about amount of substance, it is going to be a case that we're going to need to convert these masses to moles effectively, in order to really make progress on getting to what the value of X actually is, right? So and the equation we're going to use to facilitate that process is that the number of moles N is equal to the mass M divided by the molar mass Mr, right? So in this particular case here, the anhydrous mass, when it comes to working out the number of moles for magnesium sulfate, is more relevant, right? Because of course the anhydrous mass is the mass when the H2O is not present, right? So okay, so in this particular case, you've got 9.22 grams. So using this equation, the number of moles N for MgSO₄ is going to be 9.22 grams, right? Divided by the molar mass. Now, we've not actually worked out the molar mass, so I'm going to go ahead and go through that process. Okay, so I mean, there is no need to mention oxygen twice here, but yeah, so for magnesium we've got 24.3, so say Mr of MgSO₄ equals 24.3 plus, and then for sulfur we've got here 32.1, and then the O4 component, which is going to be plus effectively 4 times 16, right? And that is going to give us a value of 120.4, okay? And the units of that is going to be grams per mole. Yeah. Okay, so 120.4, right? Now, for the if you work that out, right, what you should find is you get 0.076578, right? And that's going to be in moles, right? And that's basically that's effectively rounded to 5 significant figures. Okay, so we've got what the number of moles are for MgSO₄, but really we want to be able to compare this to the number of moles for the H2O, right? And so we need to calculate a molar value for the H2O, specifically when the MgSO₄ and the H2O is in this particular state, right? So in order to work out, well, we've got this number, this mass, but this relates to the whole thing, right? The MgSO₄ and the H2O. We want what it is for this H2O specifically. So what we can do is effectively deduce that, well, this mass we have is the mass when the H2O is absent. This is the mass when the H2O is present. So if we do this mass minus this mass, so we're going to get the actual mass for specifically for the H2O, right? So on an arithmetic level, we can just say that the mass for the H2O is equal to 16.42 minus 9.22, right? And that is going to give us 7.2 grams, okay? Now we have a mass for the H2O, but we're going to need to divide that by the molar mass of H2O, right? In order to really make progress, or to use this equation. So if we say, okay, well, what's the molar mass MR of H2O? Well, that's going to be the relative atomic mass of the hydrogen. That's going to be, so 1 multiplied by 2, right? Because it's H2, and then plus the relative atomic mass of oxygen, so it's going to be plus 16. And of course, that's going to give us 18, right? So that's going to be 18 grams per mole, okay? So what we need to do at this stage is effectively simply use the equation, number of moles equals moles divided by molar mass, so that's effectively 7.2 divided by 18, right? And that gives us 0.4, okay? So that's going to be 0.4 moles. Okay, so we've got now a molar value for H2O and one for MgSO₄. However, as mentioned right at the start, the real question is, for every 1 mole of MgSO₄, how many moles of H2O are we going to have? And this is obviously not 1. So what we're going to do is make a ratio between the two and then go from there. So if I make a ratio, what I can say is the number of moles of MgSO₄ as a ratio, when we compare it as ratio to the number of moles of H2O, right? And I'm specifically putting MgSO₄ on the left hand side because in our formula it is on the left hand side, so it makes things a bit easier to work with, more easy to follow as well. So so on this side we're going to have the value we worked out here, right? So 0.076578, and that's going to be in ratio to 0.4, right? And we want to get the value on the left to be 1. And so how can we do that? Well, we can do that by dividing both. Well, let me go step by step here. So we can divide, if we divide a number by itself, you're going to get 1, right? So I'm going to divide this by 1, so by itself. So 0.076578, right? And that's going to give us 1, okay? Now, because we've done that, and because this is a ratio, what we've done on the left-hand side, we do also need to do on the right-hand side. So we also need to divide this by that same number, so 0.076578, okay? And if you do work out what that is, you should find that you get 5.2234, okay? And so in effect, and now the issue here is that we still have a value which is it's not an integer, right? And we do want an integer value for x. So what I'm actually going to do is I'm going to round that number to the closest integer value, which, if you look at this 5.2234, this of course rounds down, and it rounds down to 5. Okay, so in effect, effectively, for every 1 mole of MgSO₄, approximately, given that we've kind of rounded it, approximately what you're going to get is 5 moles of the H2O, right? And on this basis, we can conclude that x, you can say therefore, right, x is equal to 5, right? And if x is equal to 5, then of course the formula then therefore becomes MgSO₄ dot 5 H2O. Okay, and so if we go back to up here where it says enter your answer in the space provided in the formula, we can put 5, so 5 H2O. Okay,